Okay, ladies and gentlemen, we're solving this rational equation. Our first step is not to cross multiply. Our first step is to state restricted values. Remember how to find them. Okay, I wrote what the restriction is. X cannot equal 2/3. Now, if you cannot see that by looking, I want you to take your piece of paper and I want you to write this equation on your piece of paper. Whenever you're trying to find your restricted values, here's your procedure. Take what's in the denominator, so in this case it would be 3x minus 2, and set it equal to 0. So you would write 3x minus 2 equals 0, and you would solve that equation. When you did, the answer is 2/3. Now, of course, the reason that's a restricted value is if you put 2/3 into the denominator, it would become 0, and that's not allowed. But that's the little procedure for finding your restricted values. Set the denominator equal to 0 and solve that equation. That's called your trouble equation, and that helps you locate who to throw out. Now, once we cross multiply, this times 1 and this times 1, we get 2x plus 1 equals 3x minus 2. When we move things around, we end up getting a negative 1x on this side and a negative 3 on this side. When we divide by negative 1 on both sides of the equation, we get x is 3. And the reason I accept that answer, I call that's in my circle of trust, is it is not the restricted value. Okay, let's move on down. Okay, look at this rational equation. X over x plus 1 equals 2x plus 1 over x plus 1. Hopefully you remember your first step is to state the restricted value. It's pretty easy here to see that the restricted value is x cannot equal negative 1, because negative 1 would cause the denominator to become 0. Now, I'm going to do this problem a little differently than the last one, just because cross-multiplying here would get way too complicated. You'd start getting squareds in there and it would be really ugly. So the easiest way to do this problem is to multiply through by the LCD. And the LCD here is x plus 1. So I multiplied both sides of the equation by x plus 1. So over here, when these x plus 1's cancel, I'm left with x. When the x plus 1's cancel here, I'm left with 2x plus 1. When I subtract 2x, when I move it over here by subtracting it from both sides, I get a negative x equals 1. When I divide both sides of this equation by negative 1, I get x is negative 1. Uh-oh, we're in trouble. We get the answer x equals negative 1. But our restricted value is x is negative. We can't use negative 1 as an answer because it would mess up the denominator. Therefore, the answer to this problem is the solution set is the empty set. Another way to write it is no solution. No solution really means in English there are no numbers that will work, because the only one that we found was wrong. Again, I prefer my college algebra students to write empty set as the answer, but I would also accept no solution.